Hi, I'm Martin Smith, and I'm asking the question of what does an electron look like? Those little boogers that zap you every time you walk a carpet or rub up against an electric fence. I looked it up on the internet and I get a whole bunch of examples of what light does. I get a whole bunch of examples of electron orbit. I had some old ones when I was younger that had absolutely no practicality to it whatsoever, but it made some really neat designs or real neat concepts of what an electron might look like. I used one concept on the last two videos I used. I really didn't like it, but it fit the criteria that I needed, so I went ahead and used it. It was a bad one. And the one I finally have, settled down on is really, really, really hard to wrap your mind around it. So here we go, down a rabbit hole. Everything I seem to do keeps falling apart on me, and I may have come up with one that holds a little bit longer. The first model that came out was the single point model. It pretty much fails on its own because no single point has any relevant spin to it. The model that I used to have when I was little was, I used to say there was one point in space that was open where things were coming out, and another space and open where things were going back in, and it was just a flow rate, just like opening water. The model that I was using that failed miserably is this one. I modeled it after quarks. The issue with quarks is you have two negative charges and a positive charge, or two positives and a negative, and you have three systems virtually going around in simple spin. This system does work, however, it fails pretty drastically when you look at Feynman diagrams going back and forth between photons and electrons. So, all in all, I came to the conclusion that it just wasn't working and I needed another model to go after, something that might get me closer to understanding how photons interact with electrons. My present model is this one here. Very, very difficult to wrap your mind around. What this is doing is that I'm saying I'm taking one electron and both positives to create a positron. This works for the Feynman diagram because it allows a electron and a positron to come together, add a negative and a positive together, get one photon out, and another negative positive together and get another photon out. So one electron, one photon, one positron, one photon is the way they commonly think about it. But it has symmetry, it balances out. Modeling two negatives, two right hands for the negative, and right hand rule, the direction of going is where the thumb's going and the fingers go in the curl of the vortex wave. So on this one here, I'm taking two vortex waves, putting one this way, putting another one this way with the thumb going down into the page. So what's happening if I take a loop here, I have two spins, one going this way, one going this way. If it's going this direction, the spin is down. If it's going this direction, the spin is up. So what's happening are these two things are spinning in that direction. So you have twin spins. It would require angular momentum to not exist in null space. The only rules of null space proven at this time are measured in Tesla and coulombs, so I'm just going to have to choke it down and keep on going. Okay, looking at it from left hand rule, I have left hand curled this way, the other left hand curling this way, so I have vortex waves going this way, vortex waves going that direction, and they're spinning this direction. You have a negative spin this direction, so again we use the right-hand rule again. Our spin is this direction, so the direction of the electron would be up, in theory. Okay, going back to an old formula, I'm taking energy in joules to equal mc squared. I'm also making it equal to frequency times Planck's constant. I'm bringing frequency down here, my Planck's constant down here, and frequency equals mc squared. So working those out, because they are all, we have two constants, Planck's constant and the speed of light, 299792458 squared rather than 3 times 10 to the 8th, because if you use the round off 3 times 10 to the 8th, you're about 1.2% over your size. It makes quite a bit of difference in your math later on. So I'm sticking with this number squared for my speed of light. Mass of an electron you can find in almost any book. Plug them all in and I get a frequency. I go speed of light over frequency equals wavelength. I work that out and I get my wavelength. I take my old formula of 2.5 times 10 to the minus 10 to get my amplitude of my wavelength, and I pretty much just place that here. So it's a constant times the wavelength, and I'm getting this, which is giving me a radius of 6.06 times 10 to the minus 22 for the size of the electron. Remember, there's a cloud going here, spinning this direction, making a spin here, a cloud here. So this is where it gets tricky. At what size do we consider, or at what points do we consider the size to be? I'm going to the center of the vortex wave, to a center of a vortex wave, or if you prefer the center of mass to the center of mass, you have 2 mass points, and that gives you an actual spin for an electron. If the mass points were all put in the center here, all of a sudden you wouldn't be able to determine if it was spinning in any way. Problem 1 I've already explained. Problem 2, accepting an idea, a wild ass guess, and I do need to go back on this and say that as soon as you go to photons using the double helix, that is an old theory. It's a WAG, which is a wild ass guess that they have vortex waves to them. I'm assuming that is a given in this particular paper, or in this particular rabbit hole that I'm chasing down. And I'm assuming a lot of things, so do be aware that I am just grasping at straws. Like I said, it puts the momentum in the very center of the system of inertia, or this model instantly falls apart. On this double helix, remember, if it's a negative, you're using your right hand and the vortex wave is curling this direction and going in that way. If it's positive, then you, instead of putting your ink pen down to do the right hand rule, you can actually keep the ink pen in the right hand and use your left hand, like I once did on a test for the right hand rule. And the curl is going to be this direction. So in the electron, in the photon, the curls would both be hitting each other and thumbs pointed in the direction of travel. In the electron, with the 2 left hands, one would be going up this way, the other one would be also going up that direction, and they would have 2 turns. It would be 2 right hand rules. Back on here, I am dyslexic, bringing this back. I put this as a left hand rule. This is the right hand going that way. So I'm going to have to say that's my other left hand, and that's my other left hand. And I'm going to just keep on going. Dumber than rocks sometimes, what can I say? So again, the Feynman diagram, we have an electron and a positron combining. They combine and we get 2 photons coming out of the same energy as the electron, one photon with the same energy of the electron, one photon with the exact same energy of the positron. And how that would look here is we have one electron, one positron. We have a negative and positive joining up, making a photon. We have a positive and negative, again, joining up and making a photon. In order to come up with some inkling or idea of how this process works, you have to have a model first, and that's what I'm trying to devise right now, is a model that will actually not run into problems with other aspects of physics, and I look at it and say, hey, that's got to be right, versus what I was doing last time. I had a model, I didn't like the model, but I needed something because I was working with a positive and a negative, and I was trying to force a positive and negative into it. What I have found with photons is if you look at the interactions on them, if the negative side hits an electron, they are so connected that before they're even able to spin a little bit, the energy is siphoned. The energy of one siphons the energy out of the other, and they don't actually break apart. They hold together as one unit, so that when one stops, the inertia is not spinning it. As one stops, the inertia is not spinning it, and they don't break apart, because the energy of the photon is just that. It is the energy of the photon. They stay together. So this is where modeling comes in place, and where I need a good model. And the single point model with a little negative up there saying, well, we have a negative charge, so that's an electron, it just does not cut it anymore. I need something that'll go further. So going back to the fact that I need the masses in the center, we have vortex waves going around it, pushing that way, and spinning. Vortex waves turning at the speed of light, moving at the speed of light this way, moving at the speed of light this way. So yes, this electron would be spinning real fast. Going back to the vortex waves having mass in the center, I'm going to put the masses in the center here. And what I'm going to do is I'm going to use the same equation that they use for black holes. 2 times gravity over mass over the speed of light squared has to be greater than r. I'm going to put r equal to, and you also have to remember in a photon we have 2 charges. So I'm going to divide the charges up in half and say that I have 2 of them for each of 2 vortex waves. So as a photon spinning, we have a positive and a negative, or whichever way you want to derive those to be. But we do have 2 of them, so I'm going to take one of them and I'm going to work this equation for just one. And plug all the numbers in, gravitational constant, mass of the electron times 1/2, because I'm just using 1, and the speed of light squared. Come up with the radius in meters being 6.765 times 10 to the minus 58. Minus 58, you can basically take every 3 of those things and it's multiplying it by 1,000. So you can that's divisible by 3 many times. This thing is beyond small. Super small. So we can assume that the mass is found in a single tiny point right there, and right here on the other side for the other part of the electron. So in this case, we're dealing with 2 negative charges traveling at the speed of light, trapped and held together by a single bond. I have found other measurements for this on a YouTube channel, eHow Education. Look for or type in the size of an electron. And he gives out the string theory equation being 1 times 10 to the minus 35, that being from here to here, where my size, and I didn't write that down, and I should have, the radius was 6.066 times 10 to the minus 22, so it's about 1.2 times 10 to the minus 21. So you can see that the numbers are quite a bit different. He also did the classical. He wrote it up classical, and where the radius comes down to epsilon naught, basically a constant divided by epsilon naught. And he did all that out. So if you want to see how either of these were done, well, this one he did, that one he didn't. He just wrote it down. If you want to see how this one is done, this is a really good channel. And like I say, just type in the size of an electron and it should come right up for you. So the other thing you should notice with the way I did it is I had the amplitude of the wavelength equal to the wavelength times a constant. So that means that as your velocity increases, your wavelength will increase. Or is that right? As the velocity increases, yeah, your wavelength will increase. So coming up here, the diameter at rest is 1.2132 times 10 to the minus 21 meters versus the YouTube diameter numbers, which are 2.82 times 10 to the 15th and 1 times 10 to the minus 35. So there's a lot of possibilities. This one here, I brought up another possibility, and that was that when I use the amplitude formula for a string on a guitar, what happened is I came up with this number, and when I use it, I get something closer, 1.9 times 10 to the 16th, which is closer to that, but it's not quite there. A photon to a rest mass. There seems to be some kind of mathematics that's involved in there that can be switching things around. So this is using wavelength, keeping it in or keeping it out of the range of photons, not being used by photons. And it did get closer. So I have 4 possible math equations to give me the actual diameter of a electron. But anyhow, these models that I'm using with wavelength times a constant, I have wavelength times my old constant. What these will do is as you go from N1 to N2 to N3 and on up, you will find that these numbers will change. This one here, N1, the electron's moving quite a clip, and I get 1.2131, which is a little bit slower, ever so slightly slower than 1.2132 times 10 to the minus 21 meters. If you want to know what an electron looks like, I'm going to go with the dyslexic right-hand rule. Being extremely dyslexic, I also have 2 right hands, so this works for me also. And this is another possibility, and if we look at it as wave fronts going around here versus wave fronts of photons, I'm still trying to wrap my brain around how the interactions would work, and if you're doing the same, good luck, and let me know what you come out with.